Good morning, everybody. I'm going to talk about time services. This is something quite new that we are trying to offer to our community. Why? I don't know. Oh, this is me, yeah. So, role is senior systems engineer, just a humble man of science. So, and it's Miguel. I remember Miguel. So, time. We're going to talk about time. What is a second? That was a second. We can talk about second. In this case, we're going to talk about the measurement. And during the history, that was not really easy. And how to define a second? What we have is raw international, the part of measurement. Probably Julia can correct me, my French. They are in charge of keeping track of our international, the system, the international system for measurement. For the second, we keep the definition. A long time ago was like defined as 1 divided by 86,400, and that was the definition for a second. That was until 1960. Afterwards, they thought, okay, let's find a better definition for this. So they moved from that definition to they adopted the definition by using the tropical year. But then that was not enough. Because we were using astronomical facts, like the rotation of the Earth in the beginning, like the translation of the Earth afterwards, and then now quantum. Quantum is everywhere now in many presentations. But actually, quantum, we are using quantum for many things nowadays. Now you see also the definition for the second, it's quantum-based. But also in your smartphones, in your all these sort of gadgets, we are using quantum physics for producing them. So now it's probably quantum information. It's now the revolution is regarding quantum information. But quantum is already here with us for many years. The definition, here you have in a glimpse more or less what I said before. And regarding the second, and this is, let's keep in mind this. So it's a bit weird. It's the unperturbed ground state hyperfine transition frequency of the cesium 133 atom, and the delta frequency is more than 9 million hertz. What does it mean? Now this is the poor life of an electron. I like very much the electron, honestly. And so think about that. If you wake up in the morning, you are sad, you feel, or your mood is not so fine. So just start jumping. And as soon as you become tired, just count how many times you were jumping, how many jumps. Yeah, right? So now think that the electron is jumping more than 9 million times per second for offering you time. Okay? So this graph shows what is the so-called hyperfine state. So this is something that it's in use now. The quantum information revolution is using an intrinsic thing from the the particles that it's called a spin. So what happens with this is that the nucleus actually is interacting with the electrons. And what happens is that it produces, the electron is like, shifting. And it's shifting, and these are the hyperfine levels. And thanks to that shifting, which is very, very precise, imagine it's so precise that the error is 1 second in more than 1.5 million years. So think about that. Now, this is quantum, so atomic clocks. So in our case, I'm going to tell you, we are not going to introduce in our ecosystem atomic clocks, not for now. But here is how atomic clocks, the journey started with a bright physicist that you can find also in many quantum optics books, who was Ravi. So he started the journey also for having this. Nowadays, the quantum, the atomic clocks that we use, they use magnetic, let's say, they are using a magnetic field for just measuring time, or more precise frequency in this case. The new ones are the so-called optical, and it's a different way. And that's quite very, very recent technology that they are producing. So we are not yet there. We're not going to use them because it's not easy to maintain that kind of infrastructure. Our journey just will start in September. So we'll start. And then why offer time services? So I like very much Christian Huygens. I consider him one of the greatest minds in the 17th century. And he was Dutch. Probably he was still under the Spanish. When he was born, probably was still ruled by the Spanish emperor. Partially Spanish. Anyway, so what happened with him? He was really focused in astronomy, but also he was a really good mathematician. He was a man of the Renaissance, and he produced this Horologium Oscillatorum, trying also to mainly he was focused just in using for astronomical observations, but the problem back then was the longitude problem. And the longitude problem was a problem that took many centuries to find out a solution. In his case, this solution, these pendulum clocks, they sadly failed because they produce a phenomena, which is the sympathy problem, so-called. And then makes that using two of these clocks for back then for measuring longitude was impossible. More facts. The Netherlands, the fourth GDP economy in the European Union now, and the third in number of data centers. 200, I would say that probably this number it's now it's a bit higher. So let's say 300 data centers in such a small country. So there is also good fiber connectivity in the Netherlands. With one of our partners, Eurofiber. So they have more than 75,000 kilometers deployed, and probably, day by day they increase. So they have also not only in the Netherlands, but also in the whole Benelux, north of France, and also West Germany. Now, I'm talking about fiber, what has to do also with clocks, with connectivity, with, yeah. So there are many sources. The most important one that a lot of companies they are using is the so-called GNSS. So it's a constellation of satellites. In the US, the well-known is the GPS. In Europe, it's the Galileo. Russia has the GLONASS. By the way, for the Chinese, Japanese also, they have sorts of constellation. But what happens now? I mean, that we have a problem, and it's different sort of attacks that are happening also in the where sadly we have now war in the areas where they are in fight for pieces of land and whatever. So they're producing sort of different sort of attacks. One of famous one is jamming attacks. What they produce is just block the signal of the satellites. So you have to think that these satellites are geosynchronous in a synchronous orbit, meaning that they are like more than 35,000 kilometers far from us, surrounding the Earth, orbiting the Earth. So the signal is, the GPS signal actually, or I mean regarding, I would use just GPS for referring to GNSS, right? The signal is really weak. I mean, well, not so weak, but it's weak. There are other sources that we are checking. I mean, by we I mean the community, the time community, which is the low Earth orbit satellites, the LEOs, and they are the signal is more strong. They are like 600 kilometers above us, more or less. So, yeah, we have every day, I mean, news like these ones, problems with GPS, but not only because of jamming issues. It's also because we have a star that we call the sun, and every now and then, the sun produces, you know, like this so-called solar wind. So, thanks to the solar flares, we have the solar wind. Solar wind is nice when it produces these beautiful auroras, right? But it's not good for the electronics of our satellites. So, yeah, we had several in the history, in the recent history also, several outages that affected to the GPS constellation, etc., etc. And to Galileos, of course. So, we're getting time. Most of the majority of the companies, they get time thanks to these satellites. But we can get also time from other sources, which are let's say, agencies that are collaborating with the BIPM for having the so-called UTC, which is a Universal Time Coordinated. So we have one in the Netherlands, is the VSL, which is the acronym for the Dutch Meteorology Institute, more or less. We have also in the UK, you have the MPL. In the US, you have the NIST. So really important ones that they are keeping track of the time. So what can we do? We just connect to VSL in our case, and then we have an independent source for getting time.
Miguel, so just talking about keeping track of time, we have to just...
I see. Oh, I'm over. Sorry, I'm
That's okay. That's okay. But if you can, if you can round up.
I was, yeah, just fast. So, just really fast. So, POC is going to be quite simple. This is our POC time server in the lab. We're going to be connected to one of our data centers, keeping another time server. Then we will connect directly to another time server in VSL by using WDM connection. And then we will keep track also time by using also antenna on every location. That one will be connected to atomic clock in VSL. So we will get also time if even we lose connectivity to satellites. So this is also a project that we are thinking about having with SIDN to be part of this. It's for having like a sort of public, more reliable sub-time, so sub-millisecond infrastructure in the Netherlands and in Europe. Important thing is the our sub-time DB, which is an analogy to the Pyrean DB, but for time. And that's all.